Hi, this is Mr. Tomlinson, and today we're going to talk about linear functions and using functions to analyze real, authentic situations, or at least quasi-real. Okay, so some things that we need to do today, we need to be able to establish independent and dependent variables, and we need to go from verbal to algebraic representations. We also need to establish domain, interpret slopes and intercepts, and answer questions based on whatever the data tells us or the information tells us. Next class, we'll be doing linear functions and extensions using lines of best fit, which will be done on the calculator, and piecewise defined functions. Okay, so the first problem we'll look at here is this volleyball question. Suppose I need help tossing volleyballs to hitters at practice. I'll pay 1,000 yen, and yen's about the same as a rupee, so rupee yen, it doesn't make a difference to the problem because the yen and rupee are almost the same. But if I pay 1,000 yen plus 5 yen per ball tossed, how much will you make if you toss 20 volleyballs, 50 volleyballs, 200 volleyballs? And think about how you determine the number of answers above and what depends on what. Does pay depend on the balls you toss, or do the ball that you toss depend on your pay? Let's write a function that determines this situation. So let's define x to be the number of balls we toss. And let y be the amount I get paid. So if I think about it, the amount I get paid, is going to equal 1,000 yen plus 5 yen per ball toss, 5 times the number of balls. Okay? So if I just substitute the variables in there, I get y equals 1,000 plus 5x. All right? So how much will I get paid if I plug in, or if I throw 20 or 50 or 200 volleyballs? All I have to do is plug that in here. For example, I'll do the 50 one. 5 times 50 is 250. So if I say for 50 volleyballs, I would get 1,000 plus 5 times 50, which is 1,250 yen. I'll leave the other problems to you. The question is, does your pay depend on the number of balls tossed, or does the number of balls tossed depend on your pay? The independent variable, obviously, is the number of balls we toss, because the more balls we toss, the more we get paid. So the amount we get paid is definitely dependent on the number of balls we toss. Why don't you look at these situations and see if you can identify the independent and dependent variables. Go ahead and pause the video and write them down, and then press play again, and all the answers will be up there. Okay, so for number 1, we have the value of the copying machine is the dependent variable, and the number of years would be independent variable. And then in this one, the bill amount for the rental car charge is the dependent, miles driven is independent, and then the altitude in meters is the dependent, and the time we climbed is the independent. And that's it. Okay, so I added C for this problem here, right down here. It's on the second page written out, but you have to just answer this question as well. Okay, so one publishing company provides the following bid for a school journal. They charge a setup fee of this and $4.50 for each copy, whereas another publishing company charges this and $300 and a $7 setup for each copy, or $7 fee for each copy. So establish a function for each bid. I'll pause the video, see if you can establish a function for each bid. Okay, so bid one is y. First thing I did was I identified the variables. Y is the amount charged, and X is the number of school journals. Now, bid one is Y equals 1500 plus 4.5X, which is 450 per copy. And the other one is 300 plus 7X. Now, let's visualize what is going on here. If I visualize this as cost versus number of yearbooks, I've got one bid that is starting really high up on cost but not charging so much per book. Whereas the other book is not charging very much for a setup fee, but they're charging a lot more per book. So their fee is going to be like this. What's going to happen eventually at a certain number of books, this will become a worse deal than this, because initially this will be a better deal. But later, this won't be as good a deal, or this will become the better deal because they're charging less. So eventually, at this intersection point of these two lines, you're going to find that those two do not, or one becomes a better deal than the other, which I believe bid one is down here. This is bid one, which has a 300 y-intercept. And then bid two is 1500 y-intercept, but then goes up at a slower rate because they're only charging 450 per book. See if you can solve that. One thing you can do is you have two equations and two unknowns. You might remember from Algebra 1 is you can solve for x by just substituting this in for this y here and solving for x. Now, how do you identify the slopes and the intercepts of these functions? As we said, these intercepts are the y-intercepts, and they represent the cost without any yearbooks being sold. I shouldn't say yearbooks, school journals being sold. And then the slope means, for bid one, means for each additional book that you order, you're going to pay $4.50 more. And for the second one is, for each additional book, one more book, you're going to pay one more or $7 more. And that's what the slope is here. Which bid should be accepted? I'll leave that with you. Solve for the intersection and then talk to your teacher about it. Okay, now this one can get a little bit interesting because an electrician charges $90 for a 2-hour job and $140 for a 4-hour job. Assuming there's a linear relationship between the hours worked and the charge, determine a function model that represents the relationship. First thing I'm going to do is I'm going to say, well, for a 2-hour job, if we let time again be x and the charge be y, charge meaning dollars, then we know that 290 is a point on this linear relationship, and we also know that 4, 140 is also on this relationship. So what we need to do is find the linear equation that matches up for these 2 points. So the first thing you're going to do is find the slope. Pause the video and find the slope. So we do 140 minus 90 over 4 minus 2, which is 50, over 2, which is 25. What that means is for each additional hour we work, the electrician's going to charge $25 an hour. He also obviously is going to charge some fixed fee. That's the y-intercept. Because if he just shows up and they say, sorry, we don't need you anymore, they're going to have to pay a fixed fee for no hours work, but showing up. Okay, so now I'm going to put in y equals mx plus b, and I'm going to pick one of these points and plug it in along with our m. So I'm going to say y, which is 90, I'm going to choose 92, and 90 equals 25 times 2 plus b. So this is 50 plus b is equal to 90. So 90, or b is equal to 90 minus 50, or 40. Which means our model, and I'm going to move over here, our model for this is y equals 25x plus 40. Again, 40 represents the charge for just showing up, $40. 25 is the charge per hour. How much would somebody who, would an electrician charge for an 8-hour job? Just plug in 8. Y equals 25 times 8 plus 40, which is $240. That's it for this video. If you have questions, obviously talk to your teacher.